Project Euler Problem 2 asks us to take a look at the Fibonacci sequence and find the sum of all the even-valued terms less than 4 million. Here we have the start of the Fibonacci sequence, and we see that each element is the sum of the previous two. So 3 plus 5 equals 8. That's why 8 goes after 3, 5. Formally, we can write this as f sub 0 equals 0, f sub 1 equals 1, and then everybody after that is the sum of the previous two. Looking for evens, we see that the evens show up every third element, which makes sense because an odd plus an odd equals an even, and you can see that that's going to happen every 3. We can write this in summation notation as the sum of k equals 1 to m of f sub 3k, and really our whole goal here is to just solve for this. We need to figure out what m is and figure out a efficient way to calculate this. Our strategy is going to be looking for a telescoping series, which can look like this. Just as an example, if you write out the terms of the series, then we see a lot of things cancel out, like these a sub 1s. A sub 1 positive minus a sub 1, or the negative of a sub 1 cancels out, and so will the a sub 2s and the a sub 3s, and we're actually just going to be left over with this closed form expression, which is that this entire summation just equals a sub m minus a sub 0, which in this case is just the last term minus the first term. And our goal here, our strategy is going to be, can we apply this to the Fibonacci sequence itself? What would it take for us to use this? We got to figure out what this a sub n and a sub n minus 1 are. It's the biggest thing. Can I express the 3kth term of our Fibonacci sequence in terms of some difference of other elements? All I know is that it's equal to the sum of the previous two. So if I want to put a subtraction sign in there, I can just subtract somebody over. And I'm trying to solve for things for the 3kth term, so I need to re-index. And so I'm going to add 1 to all of our indices here. And we end up with an equation for f sub 3k, which is equal to the difference of these two other elements. And we can apply our summation to that and see what that expanded version of this is going to look like. And it doesn't work. And the question is, why doesn't this work? And did we do something wrong, or do we need to do something different? So we're going to take a pause here, and I want you to figure out why this didn't work and how we could approach this differently to make sure that it does. All right, the issue here is that the difference of terms was terms that were off by 2, so 3k plus 1 and 3k minus 1, but our sequence is actually every third term. So this isn't the difference of consecutive terms for us. We need to find something that's the difference of consecutive terms, meaning off by 3. So starting with 3k plus 3, which is the sum of the previous two, we can apply the sum of previous two logic again to the 3k plus 2 term. And the reason why we want to do this is now I have a 3k plus 3 term and a 3k term all in the same equation, and I can take the difference of those two. So now I have the difference of what we consider to be consecutive elements, because they're off by 3, and I can solve for this now in terms of f sub 3k with my re-indexing here. So here I'm going to minus 1 from all the indices, and that's going to give me a formula for f sub 3k, which is the difference of two consecutive elements with what I consider consecutive. Now, as a side note, you may have seen this yellow formula pop up about the Fibonacci sequence. This is a semi-well-known formula here. It's actually equivalent to what we did in the second line. We just didn't use it explicitly as it's written. Either way, this is what we're going to put inside of our summation symbol here. And we're going to take this and we're going to apply what we tried to do before, which is apply our summation symbol, write out all the terms on the right-hand side, and we're hoping this time that a bunch of the terms will cancel. And here we see that, well, it's actually going to work this time. Because our indices were off by 3, our f sub 5s are actually going to cancel, and our f sub 8s are going to cancel, and actually everything's going to end up canceling like we wanted to, except for, in this case, f sub 3m plus 2, and subtracted by f sub 2, and don't forget we have that 1/2 out in front. This is the closed form expression that is actually going to give us our final answer. And so we can say that the sum of all these even terms is equal to this closed form expression. We just need to figure out what m is. We're interested in Fibonacci numbers that are less than 4 million, and if we look down our list of Fibonacci numbers, we see that we cross the 4 million threshold at f sub 34. I only want to consider the first 33, and because there's only an even number every 3, I'm going to set m equal to 11. And from here, it's just a calculation. Thank you again for watching. Please make sure to hit the like and subscribe, and I'll see you for the next video.